There you go.
Can you see it all right?
Yes, perfect.
Okay, that's great. Well, that's a great relief because we spent about half an hour trying to get it right earlier on in the week. So I'm very pleased that it's actually working. And do let me know if there are any problems with the volume or anything, because I was listening yesterday and I thought there were some excellent presentations. It's very nice to hear my old colleague Roland Griffiths, and also a lot of the new researchers give some excellent presentations. As Jim said, I've been in this area for a long time, and the title I've been given only partially reflects what I'm going to talk about, because like any old campaigner, it's very difficult to change one track, and so you're going to get a fairly standard presentation, which I'm glad to say has changed since 1990. Trends in usage I'm going to pick up towards the end of my talk. I thought that was a topic that was covered pretty well yesterday, so I don't want to add too much just in the way of statistics about usage of different products. Potential benefits from caffeine. The only thing I don't like about that part of the title is the word potential, but what I'm really going to be talking about is caffeine, performance and well-being. And this is an area where when the caffeine wars were in progress in the 1990s, part of the debate were claims and counterclaims for health effects, but on top of this was the acknowledgement that there were other areas where one could actually demonstrate benefits of caffeine, and this is where the cognitive psychologists like myself came into the debate. And so I'm going to start in the 1990s. I realized when I was talking to the organizers that not everyone knows a lot about this area. One of them said to me, it's very rare to hear anyone talking about benefits of caffeine. From my point of view, it depends on which world you're in, and in my research domain, it's very common. So really the good data started emerging in the 1990s, and this is a typical type of effect, double-blind, placebo-controlled trial, looking at simple reaction time, so good performance and the lower reaction time scores. And what you can see is that 60 minutes after ingestion of caffeine, the caffeinated group had faster reaction times than the no caffeine group. And in another well-established sensitive measure, this is a sustained attention task where this time good performance and the higher scores. This is the number of targets detected in a detection task. And what you can see here is a nice dose response going from 0 to 3 mg of caffeine. And this type of result has been obtained many different times. And to bring you up to date, what the European Food Standards Agency decided in 2011 was when they reviewed the evidence, there was a cause and effect relationship between the consumption of caffeine and increased attention. And in order to bear the claim, a product should contain 75 mg of caffeine. And this result only applied to the adult population, and there were some concerns about giving that sort of dose of caffeine to children, which I'll get back to later in the talk. One of the areas where the benefits of caffeine are most easily demonstrated are in low alertness situations. So the idea is that caffeine has an alerting effect which returns function back to the level seen prior to the low alertness manipulation. And one of the easiest ways of looking at this is looking at what happens when people work at night. Again, this is simple reaction time, so this is the low scores are good performance, the high scores are poor performance. And if we just look at the placebo condition, you can see that reaction time slows quite dramatically over the course of the night. What we see is that initially the benefit of caffeine is quite small, but when we get to the end of the night shift, the difference between caffeine and decaffeinated conditions is much larger. So the idea is that caffeine may be particularly beneficial in low alertness situations, night work, after lunch, when the person has a minor illness like the common cold, when they're fatigued due to prolonged work, and what EFSA in 2011 concluded was that there was a cause and effect relationship between the consumption of caffeine and increased alertness. And one of the other areas where caffeine has been shown to be especially beneficial is in removing the effects of sleep deprivation, and a consensus group of the American Academy of Sleep Medicine in 2005 reviewed the area and showed that 14 out of 15 studies have shown increased wakefulness following the ingestion of caffeine by sleep-deprived volunteers. So what I've been trying to show you with these first few slides is that there's some very well established effects which have now been used in consensus meetings to try and draw some conclusions about the state of knowledge of the area. The other important thing about the area is that there are very plausible mechanisms underlying the sorts of effect that I've shown you. And I want to just talk about two of these. The first relates to the low alertness situation that I've just shown you. And what we showed in a collaborative study with Professor David Nutt was that the effects of caffeine in low alertness situations reflect changes in central noradrenaline. And before I show you the data from that study, I should just say that perhaps one of the reasons why caffeine has such a large range of behavioral effects is it affects numerous neurotransmitters. We heard yesterday a lot of discussion of effects of caffeine on dopamine, but in terms of changes in cognition and alertness, other neurotransmitters such as noradrenaline and cholinergic transmission are also very important. So this is a typical example of caffeine and neurotransmitter studies. What we typically do is use drugs, in this case a drug called clonidine, which reduces the turnover of central noradrenaline and behaviorally leads to a state which is very similar to sleep deprivation. So we can essentially create a sleep-deprived individual in a couple of hours following administration of this drug. And not too surprisingly, when people are given this drug and given the placebo, they are slower than the control group, which aren't given the drug. In contrast, if you combine the drug with caffeine, you find that the caffeine restores function to a level which isn't significantly different from the control group. So that was one method of examining the neurotransmitter basis of caffeine and low alertness. As I said, there are other effects of caffeine which don't depend on alertness being low. And one of these is that caffeine improves the speed of encoding of new information. And this has been shown to reflect cholinergic changes, and the basic effect is that these are reaction times, again, bad performance up here, good performance here, to stimuli which differ from the previous trial. So the person has to encode new stimuli. And what you can see, this is the placebo condition, and as the dose of caffeine increases, so there's faster encoding of these new stimuli. So the research strategy in this area is, first of all, to demonstrate reliable effects, then investigate the neuroscience of those mechanisms, and then look at the practical implications of some of these findings. And probably the study which demonstrated most clearly the practical implications of this was a study of caffeine and sustained military operations carried out by Lieberman and his colleagues. And this examined the effects of caffeine during US Navy SEALs Hell Week. And as the name implies, this is a training week where they get very little sleep, they have excessive work to carry out, and essentially it's both very fatiguing and very stressful. And what the authors found was that a dose of 200 milligrams improved vigilance, learning, memory and mood, even in these extreme conditions. And their conclusion was that when cognitive performance is critical and must be maintained during exposure to severe stress, administration of caffeine may provide a significant advantage. Now, of course, not many of us have the type of job which is equivalent to a US Navy SEAL, but it's important to ask the question, what is the impact of caffeine on real-life work performance? And I've examined this in two ways. One is by combining experimental techniques with real-life work, and this is what's called the after effect technique. So what you do, you measure subjective ratings and objective performance before and after work, and the idea is that the difference between those two reflects performance during the work period. So, for example, if someone has a very fatiguing day, then they will show a much bigger after effect of that day than if it's a relatively light one. And so what we did was this type of study, looking at over 100 workers, and we measured reported alertness and simple reaction time before and after work. And what we found is that those who consume more caffeine during the day were more alert and faster. Now, that's only indirect evidence of effects of caffeine on performance at work. An alternative method is to conduct epidemiological research looking at associations between caffeine consumption and accident and errors at work. We did this with a sample of over 2,500 workers who were in jobs where accident risk was quite high, and what we showed was that higher caffeine consumption was associated with half the risk of frequent cognitive failures and accidents. Cognitive failures are essentially human errors which involve problems of memory, attention, and so on. And so even in jobs where accidents are very rare, you can still show that caffeine consumption is associated with the risk of reduced human error. I think what I've said sounds a very nice story so far. Of course, with anything there's an alternative view, and this is linked a bit to what we heard from Roland's talk yesterday, and that is that actually there are no positive effects of caffeine. What caffeine actually does is just remove the negative effects of caffeine withdrawal. We heard about headaches associated with withdrawal, mood changes, and some researchers have even suggested that withdrawal is associated with impaired performance. I actually think this is unlikely to be true for a number of reasons. First, one can get effects of caffeine in animals and non-consumers who, by definition, can't be withdrawn. Secondly, one gets effects of repeated doses of caffeine. If the withdrawal explanation was correct, then the first dose should remove withdrawal, and you shouldn't get any effect at the second dose. A third point is you get it following what's called washout. Washout is where you withdraw caffeine for quite a long period of time, a week to 10 days, so that the negative withdrawal effects are no longer present. And the argument is that if the effects are due to reversal of withdrawal, you shouldn't get effects of caffeine after washout, and you do. You also get very big individual differences, even though there's the same level of withdrawal in these different personality types, and it would seem much more plausible to account for these effects in terms of arousal effects rather than reversal of withdrawal. Also, cardiovascular effects of caffeine, acute cardiovascular effects of caffeine, and effects on sleep are often explained in terms of stimulant effects of caffeine. And if one goes down this route, then why do we need to actually bring in another mechanism, namely withdrawal reversal? So, in conclusion about the big picture, and this is something that I've stated in a number of reviews over the years where different levels of evidence occur at different time periods, and this is that levels of caffeine consumed by most people have largely beneficial effects on behaviour. By behaviour, I mean alertness, attention, and so on. However, in these reviews, I've also been very careful to state that excessive consumption can lead to problems, especially in sensitive individuals. I've been a little bit careful not to be too rigid on what I consider excessive consumption, because this may clearly vary depending on the individuals one's talking about. Equally, sensitive can reflect many things. It may be a genetic sensitivity, as we heard yesterday, but I think at the time I wrote these conclusions, I was largely thinking of children. So in the last part of my talk, I want to move on to something which is very different from what I've done in the early part of my caffeine career. And this is a study of diet, behavior, and attainment with secondary school children. And this was based on a pilot study carried out by a teacher on a sample of 200 school children, and this was looking at diet and detentions. Detentions are sanctions due to bad behavior which result in a period of time remaining in school after school was finished. And what was found in this study were that a number of aspects of diet were related to these. I was initially interested because of my research on the negative effects of missing breakfast, and it wasn't until I read the report in some detail that I also noticed this section that I've highlighted in red, namely, students who consumed energy drinks were found to be 60% more likely to receive a detention.
Dr. Smith, forgive me. Hello, this is Lynn Goldman. Excuse me for cutting in, but you're going to need to begin to sum up because we're entering the time.
I have 2 more slides.
All right, wonderful. Thank you.
Okay. So the current study is a longitudinal study of 2,000 pupils. It's a longitudinal study with 2 dietary surveys at the start and the end of the year, 2 sets of measures of attainment and behaviour, controls for possible confounders, such as socioeconomic status, special educational needs, and diet. And we're currently analysing the cross-sectional data, which shows that those who often consumed energy drinks were more likely to have low attendance, receive a sanction, and poorer grades. And these effects remain significant when possible confounders were controlled. So here is just a quick example, which basically shows that those who have energy drinks more frequently are more likely to be in the low maths categorization than the high maths, where the reverse is true for those who rarely have energy drinks. So, where next? I think this is an extremely interesting finding, but we can't infer causality. We will get a clearer view of this from the longitudinal data, an analysis of dose response, and we have an intervention study based on information aimed at reducing energy drink intake given to parents and children, which will also provide additional information on the topic. Just to clarify the 2 alternative mechanisms that we want to try and differentiate between. One is that there may be energy drink may be causing the type of problems that I've just described. Alternatively, energy drink consumption may actually be an outcome, and there may be something else which is driving both the consumption of energy drinks and also related to poor attainment, attendance, and behaviour. And I think this is a critical distinction to make, and something we should have an initial answer to very quickly. Thank you.